In this presentation, I'm going to talk to you about measurement and point out some things from your textbook that I feel are really important as you understand this. First of all, some vocabulary to note as you start your introduction to statistical analysis. We often toss terms around and sometimes don't use them exactly as we work. Data is simply a word for information. It can be represented by numbers, such as test scores, words, such as male and female. It can be represented by observations, such as all students in the group leaned in while discussing the question. When you write and talk, data is plural. We say the data are collected or the data were analyzed. Statistics involves action. You will hear people say they saw the statistics. They usually mean data. Because statistics is a field of study, like geology or sociology. It is an applied field. It's the collection, it's all of the theories and methods and processes and interpretation, organization and representation of data that we can make so that we can make inferences from that data. As you work with behavioral and educational research, you will also find that the research can be classified as either qualitative or quantitative. Qualitative research uses observations, field studies, surveys, field notes, etc. to help us understand a phenomena or situation. The qualitative researcher provides us with an understanding about what is happening and what it means. Quantitative research involves measuring characteristics or effects, setting up a hypothesis or prediction, and then testing whether or not that hypothesis is probably acceptable. In this course, we are going to work with quantitative research. We will be using data that measures, and then we're going to test hypotheses through statistical procedures. As you go through this course, I want you to have a conceptual understanding of the procedures you will learn. In statistical analysis, there are often many ways to approach the hypothesis and to represent the data. You must be able to justify why you do a particular analysis. So it's going to be really important that you understand the different analyses and why we would do them. In statistics, we use a lot of Greek and Roman letters to indicate what we are doing. I've started a chart for you, which I would suggest you print out, keep it somewhere, and fill it in over the semester. You'll refer to it often as you study statistics until the symbols simply start to be part of your brain. By the way, that is definitely a scientifically supported description of learning, right? I've also posted a document that shows you how to use Microsoft Word to insert symbols when you are typing up results. So if you'll take a look at that chart that I posted, you'll see that it looks like the one that I've got on the screen. There is a place for the name, so for example, sigma, which was talked about in your textbook, and there's the symbol. It means that you sum up or you add the numbers, and then there's space for an example. So sigma, or the sum of the numbers 2, 6, 5, and 9 is 22. That's all it means, is that you add those numbers together. Another example that you'll run into is mu, and the symbol is there. All that is the mean or the average for the population. So if the test scores are 16, 25, 32, and 48, then the average is 30.25. We'll come back to that later, but I wanted to give you two examples to show you how to use that chart as you work through different statistics. Sigma is used very frequently when working with statistical equations. Don't worry too much about the number on top or the I equal 1 on the bottom. The top number is simply the total number of numbers you're going to sum. So if you're going to add together 4 numbers, there will be a 4 on the top. The bottom I equal 1 shows which number you're going to start with. But you can usually figure that out as you look at the equations, but that's what it means. The rules are important to understand, though, on page 3 of your textbook. What you will see a lot of is Rule 3. because we often add two sets of scores together to create a composite score for each participant. And I'll be pointing this out later when we use it. You'll see that we'll be adding together X and Y a lot and then working with them. Make sure that you are comfortable with exponents, which usually that is squaring something in statistics, subscripts, and you can see, notice the difference between exponents and subscripts. Subscripts go down, and they simply point out that x1 is a different number than x2, and so on. And review square roots if you need to, think back, and absolute value. Remember, absolute value is actually a distance from zero on a number line. And we use that a lot in statistics because negative numbers can cancel out positive numbers, but we still want to show that there was that much movement away from zero. So we'll be coming back to that a lot. Your textbook had a section on rounding. When you're rounding numbers to report, the most important thing to do is to be consistent. For this course, you may use the rules suggested in your textbook. I will also accept reporting to hundredths or 2 places after the decimal. This is accurate enough for the kind of analysis that we will be doing in this class. But please know that different instructors and even different publications will have different guidelines for rounding. Do not simply record all of the digits that are given by your calculations. Put some thought into it and think about what the number truly means. Just a final thought as I close with the review of measurement. We can all get caught up in numbers and data and analyze as much as we'd like. However, there are 2 questions every good researcher must deal with. First of all, are you really measuring what you say you are? This is called validity. If I'm using a child's age as a measure for his or her reading fluency, that is absurd. I'm not measuring fluency no matter how carefully I analyze the numbers. Second, are you measuring accurately? The test of this really is whether the measurement will come up the same every time, whether I measure it or my friend measures it. This is called reliability. For many traits, such as reading fluency, we have very reliable measuring tools. For others, such as a construct like happiness, we have to cobble together several measurements sometimes for some of those constructs. The takeaway is to always keep in mind what a bunch of numbers represent. They represent our best measurement of traits, characteristics, abilities, etc. related to learning. And we turn them into numbers, but we need to remember the constructs and the traits that we're really truly measuring. When we look at a 3, what does a 3 really mean? Or we look at an 11, what does an 11 really mean in this context? And that's the heart of good research and good analysis.